Let's split this whole integral into parts. It's the math, guys. Evaluate the integral of x squared e to the x dx. So I will integrate this by parts. So remember, part says if I can write this integral as the integral of u dv, then this equals uv minus the integral of v du, or as I noted, it's ultraviolet voodoo, okay? We use LIATE to help us out. In other words, we see, okay, well, if there's a logarithmic or inverse trig or algebraic or trig or exponential, then we use that for the u first in that order, right? And so in this case, we have an algebraic and an exponential. And so we'll let the algebraic be the u, okay? So let u equal x squared and then dv just be the rest, right? So e to the x dx. And now we have to fill out this table where we derive down and integrate up. In other words, du would equal 2x dx, and then integrate up, meaning v would equal e to the x. This becomes uv, so x squared times e to the x minus the integral of v du, so e to the x times 2x dx. I'll take that 2 out in front and then leave the x dx on the inside. And hopefully this is an easier integral to integrate. It is. But notice we have a product again. We have an e to the x times x underneath our integral. And so we use by parts again. We're letting u this time equal x, and then dv be the rest, be e to the x dx. And so again, we fill out another table where we derive down, integrate up. So du would be dx, integrate up, so we get v equals e to the x. So using that, we end up with x squared e to the x minus 2 times that same uv minus the integral of v du. So x e to the x, uv, minus the integral of v du, so e to the x dx. And again, hopefully this is easy integral to integrate. It is. The integral of v dx is just e to the x plus c. So we end up with x squared e to the x, distributing the negative 2, minus 2x e to the x plus 2 e to the x. And don't forget that plus c at the end. Always remember, math is everywhere.